Welcome to 30301 Digital Electronics Register and Counter Part 3. Okay, so in this session we'll discuss about the register. So first is introduction to register. Flip-flop is 1-bit memory cell. To increase the storage capacity, we have to use group of flip-flop. This group of flip-flop is known as register. The n-bit register consists of n number of flip-flop and is capable of storing n-bit word. So it can store either 0 or 1, right? So think about this is a typical register block. So it is based on or consists of flip-flop. So consider we have 4 flip-flop, 4 D flip-flop connected together in series. So this is D flip-flop, and to make it as a register we need to have clock, clear and load, right? So it could be actually synchronous register or asynchronous register. Synchronous means it depends on clock, and based on the clocks it will load the values. Asynchronous means it can load the values anytime, it doesn't depend on the clock. One more thing is it must follow the clock cycle. Say like our frequency is 1 megahertz, so our period is 1 by frequency, so it becomes 1 macrosecond. So this is our 1 microsecond. Say we have 100 microsecond time total cycle. So based on whether it is synchronous and asynchronous, so it will load the values for this period, right, or for this total microsecond. Data format and classification of register. So data can be entered in either in series or in parallel. So the important thing here to note about is series means 1 bit at a time. So it can store or transfer 1 bit at a time, and parallel means all bit at a time. So all bit should store or transfer at a time, right? So again, this is a typical register block. So we have 4 flip-flop here, flip-flop 0 to flip-flop 3. Say like we want to store these values 1 0 1 1. So we can store this parallelly, so 1 0 1 1, something like that. So this is parallel, so all bit at a time, or we can store bit in series, one at a time, like first 1 then 1 then 0 then 1, something like that, right? So this is a typical timing representation. So this is our clock. It could be activated either positive or negative edge. So based on that, so the first one is stored or transferred in series, data transferred in series. So 1011, right? So 1011, or in parallel 101 and 1. So the classification of register. So it could be classified based on input and output, also depending on application. So based on input and output, it could be classified in 4 classes. The first one is serial in, serial out, which is called as CISO. Serial in, parallel out, CPO. Parallel in, serial out, PSO. Parallel in, parallel out, PPO. Or depending on application, it could be shift register or storage register. So the PPO is a storage register and other are known as shift register. So in this lecture, we will discuss about CISO and PIPO, and I have given the assignment for CIPO and PISO, so you need to do it by yourself. So the first shift register will discuss about serial in, serial out. So say this is a 4 flip flops, like flip flop 0 to flip flop 3, 4-bit register, right? Okay, so here is the clock. This is same clock is connected to 4 of the flip flop. So we can store data through this terminal. This is D flip flop actually. So data in, and Q3 is data out. Here again data in, data out, something like that, right? So this is your serial in, and you can take serial out from here. Okay, so say like we want to store 1111 this data, right? So what we can do, so when our clock is activated, so the first bit 1 will be come here, right? So before that you consider all the flip flop have initial value 0. So this one 0 0 0 0, right? So initially uh, the 0 should come here, right? And this 0 should go there, and again this is input 0, so output should be 0. Again this 0 should come here, right? So if we consider about first cycle, initially all the flip-flop are 0. When our clock is activated, it is negative age clock, so that means, so we given the input as 1 and output becomes 1. For the second flip-flop, so this 1 goes here, right? This one goes here, so the input is 1, output is 1, the second flip-flop. For third flip-flop, so this one goes here, so input 1, so output should be here 1. And for the fourth one, this one will go here, and this input should come as output, right? So this 4 cycle will have, after 4 cycle, 1 1 1 1. So the thing is, we are giving the input serially and we are taking out the output serially as well. So this is the typical timing diagram for serial in, serial out. So Q0 through Q3, this is LSB and MSB, and this is Q0 through Q3 as well, data in clock. This is negative age clock, so it will change as negative age. So initially 0 0 0 0. Actually this is not shown 0 0, this all will be 0 0 0 0. The next one is 0 0 0 1. So 0 0 0 1. Just look at here. So this is up to the clock age. I mean, so this is at negative age. Next one is 0 0 1 1. Next one is 0 1 1 1. Just look at here. 0 1 1 1. Last one is 1 1 1 1, right? So if you go by this way, so you'll get the number. So like 0 0 0 0 0 0 0 1. So 0 0 0 1 0 0 1 1 0 0 1 1 0 1 1 1. This is 1 1 1 1 1 1 1 1 1 1, right? So you'll get this. So we will discuss about parallel in, serial out. So the circuit is like that. So here we have shift and load prime. So that means this circuit will shift when high or 1, as we are giving 1 as the input, and it will load when we are giving 0 as the input, right? So it can work on two mode, load mode, shift mode. So consider we given 0 initially, right? So if we give 0, so it will load the value, so that's why we written load mode. Okay, so if you give 0 here, so that means this becomes 1, and here this becomes 1, here this becomes 1, right? This becomes 1, and 0 goes here, so that means this is 0, this is 0, this is 0, right? So we are trying to find what should be the input of second flip-flop, third flip-flop, fourth flip-flop, or first flip-flop. Say we have given V0 here, this is V1, this is V2, this is V3. So input bit, right? So this is parallel in. So parallelly we are giving input and serially we are taking out. So just think how it works. Okay, so here the input is V0, no doubt. But what is the input here? Okay, so it's written V1 here, but we need to verify it's really V1, or it's written V2 here, V3 here. We need to verify it. We are giving V1 here, but are we getting V1 here as well? Okay, let's look at here. So this is 0, right? And another input is Q0. So this is AND gate. So if one of the input is 0, the output is 0. That's why this is 0 here as well. So this is B1. See, if one of the input is B1, the output will be B1. B1 means it could be 0 and 1, right? So the output depends on B1, not 1. So 0 and B1, the output of OR gate is B1, because B1 could be 0 and 1, and based on that, the output will be B1. So we can see we are given V1 here and we are getting V1 here. That means V1 is used as the input for second flip-flop. Similarly, for this one it will be V2, for this one it will be V3. Okay, so this circuit will work as work in load mode. Okay, so what about shift mode? So instead of 0 we have given 1. So if 1 here, so that means it becomes 0 here, it becomes 0 here, it becomes 0 here, it becomes 0 here. And this is our B3, B2, B1, B0. So obviously V0 is coming in, but what is coming here? Previously it was B1, but right now it's the shift mode. It's shifting the value. Shifting value means we are expecting this Q0 comes here, right? And this Q1 comes here, Q2 comes here. So here it's says it's Q0, but are we really getting Q0? So if you are getting Q0, that we can say this circuit will or shifting the values, right? Okay, just check here. So this becomes 1. So 1 and Q0. The output is Q0 for AND gate. Here this is 0, 0 and B1. So one of the input 0 of AND gate, the output is 0. So 0 and Q0, the OR gate output is Q0. Similarly, this is Q1, this is Q2. So we can see this Q0 is transferred to this flip-flops. That means the shifting the values. This Q1 is transferred here and this Q2 is transferred here. So we can say this circuit is working as shift register. Now consider we want to load 101 on. So if we give 101 on, so it will load 1 here, 0 here, 1 here, 0 here. But in the shift mode, what it will do, it will shift the values. So then we will get 1 bit shift. So that means we will get then 1 0 1, then 1 here, right? So it will transfer this one to this register, and this 0 to this register, and this 1 to this register, and again this registers 1 to here as a output Q3. Okay, so that's how it's loading and shifting the values in the piezo register. So you have given couple of assignment. So this is serial in, parallel out, parallel in, parallel out, and also you need to distinguish between shift register and storage register. Thank you.